Yes, so we made a bit of a switch here because but no worries, we adapt and we overcome. So MLOps in the age of generative AI. Hello everyone, hello, welcome to DevFest Istanbul. My name is Omar Elcircevi. I am also known on my socials as Omar Cevi. I have been working for Turkcell as a machine learning engineer for almost over 2 years, 2.5 years, and I've been a co-member and an organizer at the GDG Cloud Istanbul chapter, and also I'm an accelerator mentor for Google for startups. So today I want to talk about two specific things. We've been here, we've listened to many talks talking about various technologies, especially generative AI. Generative AI is really revolutionary, especially this year. We've seen so many technologies evolve and nurture from generative AI. So my aim from this talk is two specific topics. I want to have a look at machine learning operations as a machine learning engineer, and also I want to talk about how generative AI is shaping and transforming certain practices in machine learning operations, or MLOps, as we call them. So I want to start with a general overview of generative AI. Has anybody here used any kind of generative AI before? Has anybody here used like the AI avatar app? Okay. Has anybody here used ChatGPT? Yeah. Okay. So generally, generative AI is a class of artificial intelligence that doesn't just analyze data, but also generates new and original content. Now, what do I mean by this? Generally, the machine learning models analyze data and give you predictions based on this data. But generative AI tries to create new data based on the training data. Let's say, for example, we have here some examples. Have you ever heard of GitHub Copilot? Duet AI also. We use GitHub Copilot and Duet AI to accelerate our development and code development. But also, we have ChatGPT, which is a large language model created by OpenAI. I believe that we don't have sound from here, but have you ever come across where the United States presidents are playing Minecraft? These types of applications, oh, nothing is showing. Okay, so these types of applications are generally created by what we call generative AI and various algorithms that are based on transformers. I believe that the speakers before me explained the concept of generative AI and how the transformer structure actually contributed to the evolution of generative AI in this section. However, generative AI is not just about generating language or understanding language, but also we can generate pictures and generate images. We can train the model to mimic a certain style of images. Here you see, have you ever heard of DALL-E or Stable Diffusion? Yes. So, yeah, on the left you can see that these images were generated by either DALL-E or Stable Diffusion, but also you can fine-tune certain models to also give you a realistic models or realistic images of X-ray X-ray captures or X-ray images. By the way, none of these images, none of these X-rays are real. They are all generated by generative AI. So, real-world application. As you see, if you have used a ChatGPT, you have used a real-world application. But also, there are some applications that are not shown to us or not. Let's say we use them in the machine learning world. One of them is creating synthetic data for us. And we'll talk more in detail about this, but also generative AI gives us the opportunity to also talk with our documents. Not just generate images or talk with images, but also talk with our documents. Let's say, for example, I have a certain CV, or maybe I have a certain book. If I create an embedding from this book, or I create a certain vector database and use the embeddings there to try and speak with this data, large language model, and these types of applications allow me to freely understand and connect with such data. So, how does all of this connect with the machine learning operations? Well, I want to start with what is exactly machine learning operations, or MLOps. Have anybody here developed any kind of machine learning? Linear regression counts. Okay, more hands coming. So these types are machine learning algorithms, but just writing a code for a machine learning model is not all what machine learning is. There are other factors of machine learning, from configuration to feature extraction, data collection, data verification, analysis tool. We have the serving infrastructure, the monitoring. These are all blocks in the building of machine learning. And these all together, we call them the MLOps practice or the MLOps structure. So if you have a live application, if you've made any type of application of machine learning, you have in some way created an MLOps pipeline, whether it's extracting the data and then giving the data to a certain model, and then having the model predict based on the data that you've given it. This is a simple, but still, again, a machine learning model. So let's see for here, in the red area, we have a data pipeline from extraction to raw data, data creation, and then we store the data at a feature store. We then take the data from a feature store and give it to our model pipeline. After giving it to our model pipeline, if we train our model, and sometimes we directly give it to our live model, the data, yes. So if we train the model and we are satisfied with the model, we deploy the model. But if we already have a deployed model, we give it directly from the feature store. So this is a simple pipeline, basic pipeline that we can apply MLOps practices on this. So how does generative AI impact the MLOps practices? Well, as machine learning engineer, do we have any machine learning engineers here? Okay, nice. Do we have any people who worked with machine learning applications? Okay, nice. So I believe that generative AI affect MLOps in three main or major ways. One of them is model development, and the second is data management. Third is the scalability of the machine learning model or the machine learning applications. Let's delve deeper on these types of topic. So model development. For model development, we can say that code generation and algorithm development is a huge factor where generative AI contributed to certain practices. I mean, we are all developers here, and who have used the code Copilot? Or maybe Duet AI? Well, while using Copilot, even if it's not sometimes accurate, or the code that Copilot suggests is not accurate, Copilot actually suggests specific structures or suggests code for you. So therefore enhancing your experience or enhancing your, let's say, efficiency in coding and development. So we have two main points, which is a faster development, and we can explore more and various solutions while coding or designing our machine learning model. Also, we have automated testing and validation. Who here have written unit tests? Who here hates writing unit tests? Okay, I see a few hands, but I don't see others. So with generative AI, and we can generate the edge cases for our model. We can generate edge and create unit tests and simulate edge cases, and also create various and infinite testing scenarios for our model. Secondly, we have the data management side, where generative AI affects MLOps. And I see that there are two main points here, which is the first is the data generation for our model, and then we have the data augmentation. If you've worked with machine learning models, and let's say you work with really sensitive data or work with really rare data, let's say, for example, X-ray images. So X-ray images are not easy to get. You need official sources, and then you need subject matter experts to like annotate or label these types of data. It's not just about X-ray images. Also, MRI images are in the same category. So with generative AI, even if we have a small subset of these images, we can generate more images that are really, really close to real-world synthetic, real-world examples of these images. Let's say I have 100 images, and if I train a generative AI model on these 100 images, I can, let's say, generate more than 1,000 images of this specific topic. So this gives us accessibility to not just rare data, but also expensive to obtain data. Also, data augmentation. Do you know what does data augmentation mean? So data augmentation is basically, let's say you have 100 images, and 100 images of a flower, of a type of flower, let's say, and you want to, let's say, multiply these images. So you shift the images, maybe you change the colors, you change the rotation of the images. This is what we call data augmentation. With data augmentation, we can increase the model performance because it sees more scenarios of the same images. So with generative AI, we can apply it to increase our efficiency at data augmentation and change our images and increase our efficiency in our machine learning model. And finally, I want to talk about system scalability. So at the start of the year, we had only GPT-3. Maybe in 2022, we had GPT-3. Now we have GPT-4 and GPT 4.5. Now we have the Falcon model. We have open source large language models. Basically, over time, machine learning models increase in size. And as speakers before me said, operating these models, training these models is not cheap. And it is definitely expensive, whether it's in time or in money. So this graph shows us the language model size in March of 2023. Here we see the Palm family, the Bloom family, and also the GPT-4 family. I believe it wasn't disclosed at that time, but we have the GPT-3 model, which has like 175 billion parameters. These parameters take up memory and take up time to train. So generative AI models gave us the opportunity to explore various ways where we can manage training these models, not just training, but also deploying these models on various types of systems, not just a single system, but also work with distributed system. So, and because these models are so big, these models are thirsty. They gulp up your GPU just like that. So it forces us to optimize the models, maybe work as Iram Kamucu said, if you attended the speech at morning, where we work not with 64 float points, but also work with 16 float points, where and work with 8-bit float points. So the bigger the model, the more it forces us to also reduce its size with various, maybe it's with pruning or working with different float points. So, current trends. Generative AI gave us, as far as I see, we have an automation in machine learning flows. We have automation in data collection, if we generate data automatically. Model development, like using specific types of applications like GitHub Copilot or Duet AI, and it helps us in model deployment. However, it gave us also the ability to handle the data in an advanced way, where we can multiply rare data to gain more data, and multiply sensitive data to catch these edge cases while training the machine learning model. Also, the generative AI gave us the opportunity of working more on automated machine learning, where we have faster workflows, simpler workflows, and making machine learning more accessible to people who don't know how to code machine learning but want to apply machine learning with their data. And generative AI also emphasizes the importance of model explainability. That when we create a model, we need to know how to explain the model, whether it is a simple linear regression model or a generative AI model. So as I say, if you can't explain how it works, you don't know how it works. So what I think is future directions for this field in generative AI, maybe in the next few years, or maybe in the next few months, is that we will have better scalability system, not just in local systems, but also in the cloud. We will have better systems, faster GPUs, faster chips, and stronger systems. Also, generative AI raises some concerns in ethics. So it emphasizes the importance of ethical artificial intelligence and focus on ethics, which is free from bias and respects privacy and is responsible in use. However, generative AI also showed us that cross-domain applications is very important, because generative AI is applied in so many different fields that we need to evaluate different scenarios and different fields to apply machine learning and make our models or structures in machine learning operations more adaptable. Also, it emphasizes on the human AI collaboration. I believe that the human AI collaboration will be more important in the future, and in the future the applications would be more human-centric and have a solution of human-centric solutions. So I believe this was a 20 minutes. Yes, I believe that as the photo says, like a whole tsunami of information and machine learning operations. But I believe that you've catch some words and concepts from this presentations. So thank you for listening to my talk. Thank you for attending to my talk. And yes, connect with me if you have any questions. And thank you.